All right, today we're going to talk about a piece of tech that, honestly, powers a massive part of your digital world, probably without you even realizing it. We're diving into the powerful open source database MySQL. But before we get into the nitty-gritty of MySQL itself, let's just zoom out for a second. We live in a world that is just churning out an unbelievable amount of information every single second. So the big question is, how do you actually organize that mountain of data in a way that's not just fast and reliable, but actually makes any sense? Think about it like this. You could probably keep track of bowling scores for a few of your friends in a simple notebook, right? Easy enough. But what happens when your little friendly tournament goes viral? And all of a sudden you have to manage scores, shoe sizes, and favorite snacks for millions of people? Well, your notebook would become an absolute disaster. And that's the exact problem that databases were invented to solve. For decades, the most elegant answer to this kind of chaos has been the relational database. The core idea is actually pretty simple, but it was revolutionary. You just organize everything into these neat little tables, which are really just collections of rows and columns. And then you create logical connections or relations between them. But this whole idea of using tables and relations, it didn't just appear out of thin air. It was a complete revolution in how people thought about data. So let's turn back the clock a little bit and see where this all began. The entire field was basically kicked off in 1970 by a researcher at IBM named E.F. Codd. He published this groundbreaking paper that laid out the whole theory. By 74, IBM was already building a prototype, and then, just a few years later in 1979, one of the first major commercial relational databases, Oracle, hit the market, and it changed the world of tech forever. Now, Codd's original model had its own kind of academic language. What he called a relation is just what we call a table today. A tuple, that's just a row, a single record. And an attribute is simply a column. So whenever you hear these terms, just remember they're the original fancy words for the simple tables we all use every day. Okay, so that's the big idea behind relational databases. Now, let's finally meet the star of our show today. One of the most popular and influential databases ever made, MySQL. So, MySQL shows up on the scene in 1995, and its main appeal was that it was fast, it was free, it was open source, and it was pretty easy to get started with, which made it the perfect tool for the booming internet. And here's a little piece of trivia for you. The My and MySQL, it's literally named after co-founder Michael Wydenius's daughter. And its popularity is no joke. According to DB Engines, which keeps track of all this stuff, MySQL is consistently the second most popular database system in the entire world. It powers a massive, massive chunk of the web applications you and I use every single day. Okay, so we know it's popular, but how does it actually, work? Let's pop the hood and see what's really going on when your app asks MySQL for some data. You can basically think of MySQL's architecture in three distinct layers. First up, you've got the client layer. This is what handles the connection from your application and makes sure you are who you say you are. Next is the server layer, and this thing does all the heavy lifting. It understands your query, figures out the fastest way to get the data, all that logic. And finally, you have the storage layer, which is responsible for physically writing and reading the data from the disk. And that middle one, the server layer, it really is the brain of the whole operation. It's not just blindly running commands. It's like a master strategist. It takes your query, figures out the most efficient plan to execute it, and even checks a cache to see if it can answer without doing any hard work at all. It orchestrates everything. But of course, MySQL isn't the only player in the game. To really understand what makes it tick, we've got to put it head-to-head with its biggest rival, the other open-source giant, Postgres. So at a high level, the choice often comes down to this. MySQL is famous for its raw speed and simplicity. That makes it amazing for websites and apps where you're doing a lot of reading of data. PostgreSQL, on the other hand, is known for its sheer power and flexibility. It excels at really complex analytical queries and handling more advanced types of data. And if you dive a little deeper, you can see the technical trade-offs. PostgreSQL is just packed with advanced features, like MVCC, which lets it handle a ton of simultaneous reads and writes without locking everything up. And it has a wider variety of index types for different kinds of searches. MySQL historically has kept things simpler, really focusing its features on delivering that raw speed and rock-solid reliability, especially for web apps. Look, having a fast and powerful database is great, but it is completely worthless if the data inside isn't secure. In fact, an insecure database isn't just a problem, it's a disaster waiting to happen. Protecting that data is everything. I mean, we've all seen those headlines about massive data breaches, right? They are devastating. They can destroy a company's reputation and lead to huge financial losses. And that's why securing your database isn't just some tech task. It is a critical business function. So how do you actually do it? Well, it starts with the basics. Giving users only the permissions they absolutely need, nothing more. Enforcing strong passwords. Keeping your software updated. Beyond that, it means locking down network access with a firewall, encrypting your data both on the disk and when it's traveling over the network, and using coding practices that prevent common attacks like SQL injection. But security isn't just about bad guys trying to get in. Sometimes the system can get tied up in knots all by itself. A classic problem is something called a deadlock. It's kind of like two people trying to walk through a really narrow doorway at the exact same time. They both get stuck waiting for the other to move, and nothing happens. In a database, this can bring your application to a grinding halt. So how do you fix it? Well, a really common and effective solution is called the retry loop. When a deadlock happens, MySQL basically picks a victim and rolls back its transaction. Your application's code can catch that specific error, wait just a moment, and then simply try the whole thing again from the top. Usually the conflict is gone, and the transaction succeeds on the second or third try. So, from its revolutionary origins to its role today as a pillar of the modern internet, MySQL is still a titan of technology. But as data becomes arguably our most critical resource, the challenges of protecting it are only going to grow. And that's the real question, isn't it? How will these foundational tools evolve to keep it all safe? Thanks for joining me on this explainer.